Okay, class, I'm going to introduce to you a new topic on exponential functions, and the objective for today's lesson is for you to be able to describe and graph exponential functions. So let's go ahead and get started. Here's the first example. So we have a function, f of x equals to 2 to the x power, okay? This is new because you've never had an x in a function as an exponent. And here we have x as an exponent where 2 is raised to the x power. So in order to graph this function, we've created a table, and we've started off with x values of -2, -1, 0, 1, and 2. And all we're going to do is take each of these x values, plug them in to the function, and get their y value and write them in here. So if we take the first value, -2, okay, and insert that into the x value over here in this function, then what we have is 2 to the -2 power becomes 1 over 4. Okay, so we add that to the chart. The answer 1 to the 4. Now if you're wondering how we got that, let's go ahead and work that out. So 2 to the -2 power is the same as 1 over 2 squared, and that comes out to 1 over 4. Okay, so let's go ahead and take the next x value and insert that into the function, and what we get, and let's just go ahead and work that out anyway, 2 to the -1 power is the same as 1 over 2 to the 1 power, which is the same as 1 over 2. Okay, so we're going to put 1/2 over here, and then continuing on, we're going to take the 0 and add that into the function for x, and what we get is 2 to the 0 power. And if you recall, anything to the 0 power is going to be 1. Okay, so we're going to add 1 into this column next to the 0. Now we're going to take the x value of 1 and insert it into the function, and we get 2 to the 1 power, which is just 2. We'll add that to the table. And then the last one is an x value of 2, and we're going to insert that into the x value. And so 2 to the 2nd power, let's go ahead and write that, is equal to 4. So then we're going to put 4 over here. Okay, so now that we have all of our data points listed in the table, we will now plot these. Okay, so this is my x value, this is my y value. So we're going to plot -2, 1, 4. And that will be right about here on the graph. Okay, so I just plot it right here. And then the next point, -1, 1/2, will go right about here. So we'll go ahead and plot a point there. And then the next point will be 0, 1, and this is our y-intercept. Okay, y-intercept because this is where it intersects, the graph intersects the y-axis at 0, 1. So 0, 1 would be right there. So we're going to go ahead and plot a point there. Okay, now I'm going to pause here for a second and take a look at these 3 points that we plotted so far. Okay, you could see visually that this is starting to kind of curve up a little bit. As I move to the right, it's going to curve up. Okay, so let's go ahead and plot the remaining points and see where this takes us. So the next one is 1, 2, so that's going to be 1, 2, that's right there. So we'll go ahead and plot a point right over here. Okay, and then the last point, 2 comma 4, takes us at 2 comma 4. Okay, so we'll go ahead and plot a point at 2 comma 4, and that is right here. Okay, now take a look at these 5 points here. 1, 2, 3, 4, 5. If we were to connect them, you'd see that it's not a straight line, it's actually a curve. And what we see is that it actually moves up, and it starts to go up faster as we move to the right on the x-axis. Okay, so if we were to connect these, see that this curve would look like this. Okay, and if we plotted more points by adding more x values to the function, okay, you would see that this line actually takes off in this direction. So we'll put an arrow in here indicating that this function continues. Okay, and then the other side would also be true. So if we continue this negative value to -3, -4, -5, and continue to plot those values, we'd see that this line actually moves closer and closer to the x-axis. So let's go ahead and draw that. Okay, so it moves closer and closer to the x-axis. Now I'm going to go ahead and zoom in, okay, and focus in on this graph for a minute, and you'll see that as this graph gets closer and closer to the x-axis, as it moves further to the left on the x-axis, it actually will never touch the x-axis, but it is approaching the x-axis. And when you have that scenario, okay, what we call the x-axis, this becomes what's called the asymptote. Asymptote. Okay, an asymptote is a line, okay, it's an invisible line where the graph is approaching it and it gets closer and closer but never touches it. So that's called the asymptote. Okay, now let's go ahead and move on to the next example. So here we're going to show you how to write an exponential function. So we're going to go backwards, right? So in the previous example, you were given a data table, a partial data table. You had to find the y values and then go ahead and plot the graph. Now you're given a data table and you're going to come up with the exponential function. So how do we do that? First, we need to recognize the form of the exponential function, and that form is f of x is equal to, and I'm going to call this a times b to the x power. Okay, f of x is equal to a times b to the x power. Now, what we need to do is find the value of b and find the value of a. Okay, so how do we do that? First thing we're going to do is find the value of b. And what we're going to do that is take a look at this data table. And we're going to focus in on the f of x column, or the what's called the y column. Okay, and what we're going to do is just look at the ratios. We're going to compare the second value and divide it by the first value. Okay, so we're going to take the second value and divide by the first value. So 12 divided by 4 we find is equal to 3. Okay, now normally we would stop here, but I would suggest that you check the remaining ratios just to make sure that this ratio continues to be 3. So we're going to take the third value and divide it by the second value. Okay, so we're going to take 36 and divide that by 12, and we see that that is equal to 3. Okay, and then we will continue that with the fourth to the third. So let's say 108 divided by 36, and we will see that that is equal to 3. And then the last one, 324 divided by 108 is also equal to 3. Okay, so you see that in every case the ratio is 3. So now we found the value of b right here. Okay, so we can go ahead and insert that. So our function so far is f of x is equal to, we don't know what a is, so we're going to just say a, but we do know what b is. Okay, b is now 3 to the x power. Okay, and now the last step is to find a. Okay, well, how do we find a? The best way to find a is to take the x value, okay, plug that in to this function and figure out what a needs to be in order for it to be 4. Okay, now why 4? Well, 0 is paired up with 4 in our data table. Okay, so we know these go together. So if we were to plug this in, we know that our y value ultimately has to equal 4. Okay, so let's go ahead and plug 0 in over here. Then we will get, let's say f of 0 is now equal to some value of a times 3 to the 0 power. Okay, and when we go ahead and solve this, well, not necessarily solve it, but when x is 0, f of 0, we get some number a times 1. Okay, 3 to the 0 power is 1. Okay, so now the question is, what does a need to be so that this value, which is this value, is equal to 4? Okay, well, a has to be equal to 4. A has to be equal to 4. And so therefore we know a is 4, and so our final function is f of x is equal to 4 times 3 to the 0, I'm sorry, to the x power. Okay, so that is our answer. Okay, and then the next, or the last example, is how to find the function, right, the exponential function from a graph. Well, this is very similar to from doing it from a table. Okay, the only difference is you have to start with the graph. So let's go ahead and take those points and turn them into a data table. Okay, so we have our table, our x and our f of x, and let's go ahead and put the data points in. So we're going to start with this point here. We're always going to start with the leftmost point, and so this one is 0, 128. So we'll go ahead and add that in, 0, 128. The next point is 164. So we'll go ahead and add 164. Okay. And the third point is 232. And the fourth point is 4, 8. 4, 8. And the last point is 5, 4. So we'll go ahead and write that in. 5, 4. Okay, now that we have a data table, the steps to coming up with the function is exactly like what we did in the previous example. So the first thing we need to do is write out the form. Okay, so we know that f of x is equal to some number a times some number b raised to the x power. Okay, so we're going to go ahead and start with finding our b, and to do that we need to take the second value of this column, which is our y value, and divide it by 128. Okay, so we'll go ahead and do that. Okay, the direction of the division is important. It's 64 divided by 128, not the other way around. So 64 divided by 128 is 1/2. Okay, and then we're going to take the third value and divide that by 64. So 32 divided by 64 is 1/2. And then we'll do the same. Okay, we can't really do the same here, okay, because we have in interval 1, we're going from 0 to 1, 2, we skip 3, and we're going to 4. So we actually need a point for 3, okay? Since it's not on the graph, I'm going to go ahead and add that. And we find that it is 3, 16. So we're going to go ahead and insert that. Okay, so we have 3 and 16. Now we can continue that ratio. Take the fourth value and divide that into the third. And so 16 divided by 32, 32 is equal to 1/2. And you'll see that all the other ratios end up being 1/2. Okay, so this confirms for us that this is an exponential function. And so we know now that our b value is equivalent to 1/2. Okay, so let's go ahead and write the function. We know this is going to be f of x is equal to some number a, we haven't figured that out yet, times b, which we know to be 1/2, and it's going to be raised to the x power. Okay, so we are halfway there. So now to find a, we're going to use the x value of 0, which is our y-intercept, okay, and we're going to plug that in, and what we see is that f of 0 is equal to some number a times 1/2 raised to the 0 power. Okay? And we know that anything raised to the 0 power is 1. Okay? So then our function simplifies to f of 0 is equal to a times 1. Okay? So then what does a, the next question to ask is, what does a need to be in order for our y value to be 128? Well, let's go ahead and stick that into the function. So f of 0 is really 128, and that is equal to a times 1. Okay? And so we know then that a is essentially equal to 128. So then my final function is f of x is equal to, we solve for a, so we now know it's 128 times our b, which we already solved to be 1/2 to the x power. And that is our answer. Okay? All right. Hopefully that made sense. If any of this was not clear to you, I highly recommend that you go back to the beginning of this video and listen to it again. Thank you.